But I figured out how to do it. That's improvement.
Well, that's good. But I might as well go walk through it. How you feeling? Feeling better? So, what you recognize is that tangent squared can be rewritten in terms of secants. So, tangent squared is secant squared minus 1, and that would go over your secant plus 1. And then we still have a plus 1 here. Now, secant squared minus 1 is secant squared a perfect square. Is 1 a perfect square? Is that a subtraction symbol? If you've said yes to all 3 things, then you need this product. I get it? It's product then? Oh, that was a tad. So you get secant plus 1, secant minus 1 over secant plus 1 plus 1. Now, since these parts in the fraction are all terms, this goes away, like you were saying, and then you get secant minus 1 plus 1, which means you have a secant and you destroy it.
I figured that out.
What else am I going to look at? 41. In 41, you have a bunch of different options as far as how to start it. Now, one of the things that you can do is rewrite the interior, the parentheses, or basically rewrite everything in terms of sines and cosines. Since you have cosines, you have a sine, you have cotangent, you have tangent, you have that stuff there. And see what happens. Now, if I do that, I'm going to have a cosine, sine, times cosine over 1, sine cosine, plus sine over 1. You okay with that? Now, right off the bat, that goes away. So on the inside, excuse me, on the inside you have how many sines? 2. So you have cosine, sine, times 2 sine. What drops? A sine. Does the 2 go anywhere? No, because it's not squared. It's think of this as x over y times 2y. The 2 doesn't go anywhere, just the y does. And you get 2 cosine. Does that make sense? And that's if you crossed out the 2 and left the sign, that's because you were in the what do you call it? I don't want to say in the rut, but you were in the mindset of power rules. And this is the power; it's a monomial. Yes, ma'am.
Can you do 45?
Do you have $1 today?
Not on me. Oh yeah, it's free money. That's at home. I didn't even bring it today. Because I didn't feel like it. I feel like this somehow ends up being that one, the like tan squared equals 1 plus 3.
Yep, we have to do a common denominator on this one. It just gets a little messy. Oh, by the way, since I know that, what's today's date? 24th. All right, I know that they have to complete the last of their fire drills this week. And if you think about it, today and tomorrow are the nicest 2 days of the week. So if by chance something ever does happen in this class, yeah, I think we've discussed this. Where do we go? I don't know.
To the stop sign.
Stop sign, because it makes sense. You can see it, so we can get there. We can be safely together. All right, so this one here, you have to get a common denominator. So common denominator here would just be to put tangent and 1 plus secant together. So the fraction on the left needs a tangent. The fraction on the right needs to be multiplied by a 1 plus secant. So in this case, you have to FOIL that out. So when you FOIL that out, you're going to get 1 plus 2 secant plus secant squared. Numerator, then I can simplify that by rewriting tangent squared in terms of secant squared minus 1. And that's your best bet. So I have a secant squared minus 1 plus 1 plus 2 secant plus secant squared. And then that just comes along. We okay with that? If I simplify that numerator, I'm going to get 2 secant squared plus 2 secant. Okay with that? What does the numerator have in common with each other? 2 secant. Factor out of 2 secant. And I'm left with secant plus 1 over what simplifies? Yeah, the secant plus 1 and the 1 plus secant, it's the same thing. It's just, 2 plus 3 is 3 plus 2. Okay. So lastly then, I'm going to rewrite secant and tangent in terms of sines and cosines. So if I do that, I'm going to get, let's slide this up. Is everybody okay up to this point? Not as fuzzy as it was 3 days ago, I hope. So this is the same thing as saying 2 over cosine, because it's 2 times secant, 2 over cosine, divided by sine and cosine. I rewrote that in terms of a giant complex fraction. Okay? So now I just have to bring the bottom and multiply by the reciprocal. So I wind up with then 2 over cosine, times cosine sine, which gives me 2 over sine, which is 2 cosine. Aren't these fun puzzles?
I don't do puzzles for a reason.
It's a good thing I gave you, I don't know, like 200 of them to look at. Did any of you guys actually just Google the answer keys for any of these?
I tried to Google this one and I couldn't find it.
This is a really old worksheet. This one's tough to find any info on. I honestly don't know where they got this worksheet. I was given this worksheet 9 years ago when I first taught this class when it was called Advanced Algebra. I think Mr. Tames or Mr. Tony gave it to me, who you guys don't know, and then went from there. Or was it Mr. Tolman? I don't know. But it's been the same bad photocopy of it for at least 10 years, and it's not going to go away, because it's great. I love it. It's a fun worksheet. Any others? 35. Do you have $1? How's your foot? Is it getting better? Yeah? Are you going to actually go running again? Remember the trick that I told you guys about simplify when you had verify? If your verify starts with addition and it ends in multiplication, bless you, that usually means that there was some sort of common denominator done. Or if it starts in addition, or starts with multiplication, goes to addition, it's kind of the same idea. You had to somehow figure out a common denominator to combine things together. So in 35, if you will, I told you guys I had my worked out answer keys for these things if you wanted to look at them in the morning. It was on the desk. Nobody came in to look. Answers. So this one here, the easiest thing to do is to rewrite cotangent and tangent in terms of sines and cosines. Get a common denominator. So you have cosine over sine plus sine over cosine. Common denominator between these two is going to be sine times cosine. Fraction on the left needs a, so you get cosine squared. Fraction on the right needs a, and cosine squared plus sine squared is? There's many ways to do it.
Okay.
Yeah, absolutely. What'd you do?
I canceled. So like I did that, and then I canceled. Like I put it into two fractions instead of one.
Oh yeah. That's fine.
And I just canceled.
Yeah, that's fine. I think it's more work because. You did cosine squared over sine cosine, and then sine squared over sine cosine.
Something like that.
It just seems like it'd be a lot more work.
I don't know what it is. Like, maybe I just did it in my head and didn't write it down very well. Sometimes I do that too.
Oh, you didn't multiply it through. Okay. Here's what you did. You got your common denominator like you would, but you forgot to multiply the top by the square. Yeah, so you just, I think you probably saw that you were going to wind up with this cosine squared, sine squared, but you gotta show that though. Does that make sense?
Yeah.
You saw that you were going to get to that, so I think you were just simplifying quickly.
Probably.
That's all. Just be careful on that. Don't jump too many steps. All right. Did I tell you guys what QED stands for? No. It's Latin for which has been shown. It's what fancy people put on proofs. Quantorum edimum demonstratum. Something. I'm not making it worth. It's Latin. Ask your mom; she knows what it is. You're like, oh, I guess I can. Well, I gotta take my mom off in half. Have we had enough of this? No. All right, sweet. Let's do stuff with equations. It doesn't go away. It doesn't go away. What happens now is that we're going to be able to use. Don't write it down. Don't write it down. I made this a copy of this for you guys. What happens with this stuff now is that we're going to be able to do equations that have properties, and we've actually done a few of these already. When we had that's just that sine squared, cosine squared stuff, where you had to rewrite.
Will this help understand
What do you mean?
Will this, like, help
Yeah. Because that's the hard stuff. This is easy.
So this will help with the mind of this first.
But you have to know how to do some of that.
Because you have to know how the properties in order to get them to work with this.
That makes more sense. Okay.
So what I want to do is I want to walk you through a couple of these and talk about how we solve the equations again via one revolution, or general solution. Okay? So I'm going to look right away at number 3. And if you recall, this looks eerily similar to what we did a couple of weeks ago. I think right before spring break, I think, when we solved the equations. Now, when we solved the equations before, we had to utilize some of the Pythagorean identities in order to solve for x. Well, the trick was, I have a cosine squared and a sine. What I would do was rewrite the squared term to make it look like the non-squared term, because I can work backwards to that. So knowing that cosine squared is 1 minus sine squared, I would use that substitution. So we would do this. 2, 1 minus sine squared minus 3 sine is 0. Okay? Might put my x in here later, because we're solving for it. So we use that Pythagorean identity that we had in the past, and we redistribute and rewrite. We have 2 minus 2 sine squared theta minus 3 sine theta equals 0. Which means we have a trinomial with the nasty word of sine in it. When we have to factor something, we always want our first term to be positive. So I'm going to move everything to the right-hand side. In doing that, I'm going to get 2 sine squared plus 3 sine minus 2 is 0. And at this point, you guys had 1 of 2 ways to set it up. You can just go ahead and factor it with the signs in it, or some of you guys utilize that, remember what we called U substitution? We just let U look like something that looked like crap and just was easier to work with, and just redo it. I don't think it's terrible when it's just a sign value, or I don't think it's horrible, but I think I'm just going to write this one out in long form. So what's 2 times negative 2? What times what is negative 4 that adds together to get 3? Negative 1 and 4. So this means we would factor this via grouping. 2 sine squared theta minus 1 sine theta plus 4 sine theta minus 2 is 0. What's 2? If it was 2 and 2, what would it add to then? See what I'm saying? So now you would factor this via grouping. The first chunk, they only have in common a sine. So I'd factor out a sine of theta. And I'm left with 2 sine. And the other one, what do they have in common? A 2. Factor out a 2. And I get 2 sine theta minus 1 is 0. And just like every other time you had to factor via grouping, if the 2 things that were in parentheses are the same thing, that's a good sign. SIG. So if these 2 are the same, I'm going to write it down. We have 2 sine theta minus 1. That'll have to equal 0. And the other one would be what's left over. Sine of theta plus 2 is 0. So now it goes back to the what angle has a sine of 1/2. Careful. What triangle has the 1s and 2s? 30, 60, 90. So it'll be a 30-degree angle. So 30, otherwise known as pi over 6, within 1 revolution, sine is positive in the first quadrant. And where else is sine positive? The second quadrant. Reference angle, pi over 6, which means you are at 6. Ah, yes, the unit circle, your best friend. And then the other one would be, what angle has a sine of -2? Can you have a sine of -2? No. And that would be my answers within one revolution. Oh, Trey. So much fun. Did you guys have a good weekend? I did. I didn't get as much grading done as I wanted to, but whatever. It was nice out. Yes, sir.
How did you get from pi over 6 to 5 pi over 6?
Reference angle. Since in the first quadrant, pi over 6 is the reference angle, sine is positive in the second quadrant. It comes up pi over 6. Pi over 6, 1/6 up from a whole is 5/6. Let's try another one. If you look at this one, excuse me, this is number 5, I believe. It's the next one on there, or right below it. You have cosecant squared minus cotangent minus 1 is 0. So let's think here. I believe there was a Pythagorean identity that dealt with cosecants and cotangents. And if I'm not mistaken, it was 1 plus cotangent squared is cosecant squared. So, which one do you think I'm going to rewrite? Yeah, since Christmas, I've only dropped it 4 times. Apparently so. Look what we're doing! Trig identities!
Oh, is this where you have to prove the left side is equal to the right side?
Oh, we just got done with some of that stuff.
It's not fun.
No, it's not, but now we're doing equations with it.
You know stuff I don't know.
Hey, do. Substituting cosecant squared and refactored?
Oh, is this like sine squared plus cosine
Yeah.
squared is equal to tangent squared? It's not fun.
No, it's not. Remember, where's that awful worksheet? Remember that one?
Oh, yeah. Keep saying that because it's just not fun.
What's up? Is it at 9? Yes. Because he's right on time. Oh, no, that's fine. So now what do you have? A headache. Besides a headache. Yeah. You write it with cotangent squared, theta minus cotangent, theta equals 0. What's your first rule of factoring? Take out your GCF. Good. Take out the GCF. What do they have in common? A cotangent. So you have a cotangent. And now you have 2 terms to set equal to 0. Excuse me. So we have cotangent of theta is 0, and cotangent theta minus 1 is 0. Cotangent was what over what?
Cosine over sine.
Well, yeah, but it's cosine over sine, so it's x over y. Okay. So remember, it's just this means what angle has a cotangent value of 0. Zeros occur on the quadrantals. It's a matter of figuring out which one is which, okay? So if you're on your quadrantals, here's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cotangent is x over y, which means y has to be 1. So where is x 0? Top and bottom. Okay? So we're at pi over 2, 3 pi over 2. Yeah, you remember this now?
Is this meant to limit the domain as well, or is that?
We are, this one was all within one ringy dingy.
Okay, cool.
See you, Clay. Okay. And then the other one is going to be where is cotangent equal to 1? What angle has a cotangent of 1? You're giving me the word face. You know this. What angle has a tangent of 1? 45. So what angle has a cotangent of 1? 45. It's the same angle. Because the inverse, if you remember, the reciprocal of root 2 over 2 over root 2 over 2 is still going to be root 2 over 2 over root 2 over 2. So it's still going to be at all of your 45s. Oh, I'm sorry. This is positive. What two quadrants is tangent and cotangent positive? 1 and 3. So at 1 and 3, you're going to be at pi over 4. And if you drop pi over 4 into the third quadrant, it was add a fourth to a whole, you get oh, the unit circle might have started to fizzle on us, I think. That's for when you're just doing just a singular tangent, like when it just says solve this. When you're in the equations, you're talking about the instruction will say within a revolution or general solution. You don't need to worry about the other ones. That was just the precursor to getting to that. Okay. You don't have to worry about the, your restricted domain of pi over 2, negative pi over 2 like that to come around. You don't have to worry about that in these types of equations. Okay. That was just that one hit, one term. Okay. What's next? Well, sometimes you have to do stuff like this. Turn that down. It's probably a little loud in your ears. Come to 2 cosine theta equals secant theta. What? Not quite sure what to do here.
I know that's
forgot.
Segway.
Never saw the movie, I just remember the voice. Gotta go out and get me some taters.
Never saw the movie though?
Nope.
No, that's pretty good. That's really
I did
old
something
though.
wrong because I just got 1.
How do I move that 1 over cosine to the other side?
No, just kidding.
Multiply. If I multiply both sides by cosine, I'm going to multiply this side by cosine. What do I get on the right-hand side? I get 1, right? On the other side, if I multiply by cosine, I get 2 cosine squared of a beautiful theta. Say nothing to me all year long, and you just shake your head the one time I sing. Now what? I open the door. You're right. Welcome back. We've missed you. No. Divide by 2.
Last. I hope I do
which means now I have to take the square root. So this works out to be what angle has a cosine value of plus or minus 1 over root 2. Now I'm not going to rationalize that because this will help me to remember what angle I'm looking at. It's the 45, isn't it? Excuse me. So my 45's my pi over 4, and since it's plus minus, that means it's every single one of them. Okay? All right? It's all 4 of them. Because cosine's positive 1 and 4, cosine's negative 2 and 3. So it's your answers will be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 within one revolution. It's a little trick that you will see, especially when you have inverse ones. You just multiply by the reciprocal, and you might have put the square unit, and you just take a square root and go backwards. Okay. I don't think it's bad. Quite honestly, I don't think that there's anything else on here, on this first page here, that's going to be very difficult for you guys to figure out. Try and get as many of these done today on this side. We'll talk about the other stuff on the other side tomorrow, and then we'll get into some of the other. I do have a couple other goofy ones as well. I'm planning on done with this Thursday. Okay? No, we'll do Thursday. We'll go Thursday. That way it gives us a little extra time on equations. Because it's been a while since we had to worry about revolutions and things like that. And I was looking at, I didn't get all my geometry stuff graded over the weekend, but I did kind of look at our schedule. And I kind of mapped out kind of a rough idea of where it kind of goes. Is that this coming Friday then, so we'll finish, what do we have, Monday, Tuesday, Wednesday, Thursday, Friday. Here's will be our quizam thing, or whatever. Let's call it a quest. We haven't done that yet. So it's, what I say, 2 simplified, 2 verified, and 2 equations. 6 questions. I know some of you guys have the AP Euro, bless you, but then you guys will just do it on Friday.
So what are you guys going to do Friday then?
Keep learning.
Nothing?
No, we'll start sequences in series on Friday. It's formula work. Okay? So we'll start sequences in series here, which is basically we start in chapter 11, we'll go to 11.2. I'm not going to do 11.1. 11.1 sucks. It's stupid. It's more of a pain in the butt to anybody than anything else. No offense if you like it. But. And then that'll get us next week, the week of the 1st, May 1st. Through that week, we'll probably be able to be done with chapter 11 on that Friday, because it's a real quick chapter. And then the week of the 8th, and then we'll finish out probably around May 23rd or 24th will be our probability and stats. And then that'll give us, I'm kind of buffering in a good solid 4 to 5 days of review for the final now. Okay? That's kind of where I'm looking at. Yes, sir? Okay. That's fine. You know where everything is. The one of the things I will say, if you guys don't know anything about cards, get a deck of cards. They're 50 cents. that we understand when I say what's the probability of getting a jack or a red. You know how many of them there are? Because I've found out over the past few years, not as many students play cards anymore. Maybe we'll get what was it? I forgot what it's called. Never mind. Yeah. Oh, is it? No, it's not.
I was trying to get like the +4
Yeah.
colors left. Just like Uno, everyone thinks they're
Yeah, that gives us plenty of time to get through all of this stuff. All right, plenty of time. Statistic-wise, what we do in here, I don't really get into too much stat. I get through like kind of the basics. What we do is standard deviation. We do the normal curve. You know how we talk a little bit about outliers, stuff like that. Mean, we don't really do mean, median, no, but we do a real scratch the surface thing. I'll play it by ear as far as, well, I'll probably be able to get you guys some sort of review stuff if you get ever so inclined. Since we have the probability test, I could get it to you probably around the 19th or so of May, mid-May, that we still have a couple of weeks to start going through it. Shouldn't be an issue at all. I'll probably just post it. I don't need to make copies of it. We'll see how many pages it is. Okay. We're almost done. Yay!
I can't do this.
Yay!
Yay!
Yay! Finish that.